I guess all these great systems, all these great technology is always improving, right? But I think the common theme that we all have as service hardware providers, providing the best solution for our customers. I think that's the one thing we all have in common. But I also want to thank you, Ted, for allowing us to present and to represent Riegl here at the many years we've been here. But also, I want to also thank you, Robin, for taking care of our tickets. So probably the best thing. Love it. Yeah, so let's go ahead and get started. Let's go ahead and slow down a little bit. Go from mobile down to terrestrial. Yeah. Let's take a look at the agenda real quick. The VZ600i has been released now for nearly 2.5 years. Within that 2.5 years, we did a lot of testing, bench tests, right? We try to put the system to the ringer. Historically, the separation between the VZ400i and the VZ600i is a 7-year gap. So it's a large gap for a new system, but this new system has certainly delivered on many levels. Some new development on the software side. Historically, Riegl has always used cylindrical targets, and Riegl will always use cylindrical targets to control the data to absolute value. But beyond the cylindrical target, we also recently introduced flat target too as well. This could be used in many different applications, such as scanning warehouses, big Amazon center. We can just put these targets right on the wall. But recently I've done some testing with it, right? So I don't want to talk about it unless I've done some testing and have some absolute real value, real world values, especially tying it down to absolute control. Very interesting coming up slides here shortly. And then the last thing, probably the most compelling topic of this presentation, it's going to be from our clients. I think the proof is in the pudding when our clients talk about it, when our clients use it, and when our clients actually demonstrate it and can see what the 600i can possibly do. So let's just go ahead and look at the lineup of our terrestrial laser scanners. On the left and the right, we have our proven I-series systems. The 400i has been a very robust, proven system in the surveying, engineering, transportation, and market. And then, of course, the 2000i is our long-range scanner that can be used for mining, slope stability, monitoring. But nevertheless, all these systems, whether it's long-range or 400i or 2000i, very dynamic ranging, right? So we can scan at 0.5 meter down to 2,500 meters. But now, to the new lineup, our terrestrial laser scanner is the VZ600i. And this system has changed the dynamic of terrestrial laser scanning. Coming from a background of, working at Riegl for the last 16 years, I've seen the challenges, I've seen the changes, and I've seen the adaptation stage, and I've seen the limitation of capability of these scanners. In fact, when I first started doing a mile worth of road profiling using terrestrial laser scanner was never really an option, right? They were heavy, they were slow, and they collected a lot of data. You needed computers and stuff to acquire the data with. So you had a lot of hardware, so it's really difficult to scan miles of roads in the past. But now, present day, I think with the 600i has changed some of those questions and hesitation to tackle on a mile with the road. Let's go ahead and look at the specs. I don't want to talk about too much about it, so I'll just highlight some of the specs. And of course, we'll be here to talk about the scanner outside in more detail if you want. Yeah. So here's the performance of the laser scanner. All of our terrestrial laser scanners have something called dynamic ranging, right? So Riegl uses a time-of-flight technology to capture data in space. So it's all timing at this point and then using the speed of light. So whether you want to scan indoor or outdoor, it doesn't matter. The user has the capability to select different pulse repetition rate, right? So depending on how fast the mirror spins, dictates the range of your scan. 99% of the time, you're probably going to scan in a 2.2 megahertz range, which collects data up to 250 meters. And if you want to slow it down, it can reach all the way up to 1,000 meters. So it gives the user the flexibility to not only scan near range, but also to scan long range too as well. And long range is very important for us as we move into our automated processing, automated registration, is because we use planar surfaces from near range and short range to get a very high accuracy solution when we do the cloud-to-cloud based registration, especially utilizing the onboard registration. So as you're scanning, the scanner can detect different plane from the first scan position to the next scan position to the next scan position and sticks itself together. And then by the time you download the data, you have a completely registered homogenized point cloud, and then we have a dedicated workflow to get absolute value. Other highlights I want to point out, the accuracy and precision of all these terrestrial laser scanners, whether you buy it from any manufacturer, they all have to meet certain specification, right? The DOT, the surveying, the demanding surveying, and engineering specification. But newly to this system, we can establish half a millimeter precision. There's a special precision mode. Now, why would you ever need that in transportation? I don't think you do. But if you were to want to use it, I can see it using for floor flatness, right? Scanning substations when you want to look at small cables or isolators and such, right? So you can take the precision down to a half a mil. Of course, it's just going to give you more time. And all it is just more sample, that's all. Okay, let's talk about speed, right? So one thing I forgot to talk about is productivity. I think productivity is very important in terrestrial laser scanning. I think productivity doesn't just start in the field, but it ends in the classroom with a deliverable point cloud or to the client or to your engineers for designs or whatever application, right? So productivity does not just start and end in the field. So the system is quite fast. When I say fast, it's an understatement. It's lightning fast. Within 25 seconds, the system can acquire data, full scan at 6 millimeter resolution at 10 meter range in 25 seconds. You know? And that also includes image capture too as well. Right? So what does that benefit? Well, now we can move faster, move longer within the day, and cover more with a high-speed scanner, right? But I think speed does not just justify everything. I think workflow, control setup, and that's what we'll talk about later on when Jason presents it in the real-world application. So the average scan, we like to the preset that we like to train a customer on is a 6 millimeter resolution at 10 meter range, right? So why that resolution? This system is completely user-defined. If I had to capture something at 1 millimeter at 10 meter range, I can certainly do it, but it's just going to cost you more time because we just time of flight. So why has this 6 millimeters always been brought up? It's because it's optimized. It's optimized to get the top of curve, the bottom of curve, your gutters, your corners, 150 feet outside of scope of work on road projects, power lines, and it also is fast, right? So good resolution and very short amount of time. That's why we always push for the 6 millimeter. It's optimized for most of your survey. Of course, if you quantify, if you were to scale that down, on average, on paper, it's 60 scans per an hour, right? So a scan a minute, right? That's assuming that you picked it up and you know where you're going and stuff like that. But real-world tests, and I've done many, and I quantify every single test that I've done, whether I scan indoor, outdoor, long corridor projects, parking lot, altitude survey. I'm averaging right now 1 minute and 27 seconds per scan position from start to start, meaning that start, done, pick up, and move to 1 minute and 27 seconds. That's real-world tests. But perhaps the biggest change to the VZ600i between the 409 and 2009, it's weight. I think we listened to a customer. I think we delivered to a customer a very light, but yet robust system, and it's only 13 pounds, which is a blessing coming from the first generation, really, of all these scanners, right? They were really big and heavy. I think I remember we couldn't move the scanner more than 10 times in a day 15 years ago. I couldn't do it. Maybe you can, but yeah, so weight is one of the biggest improvement of all of our terrestrial laser scanning line. Although the system is 2 years new to us, we still support all of our terrestrial laser scanning line, right? So, and new developments for the 600i also is then passed down to the predecessor, the 400i too as well. So, for example, just don't want to talk about it too much, but this thing has a mobile feature. So I could put this on a vehicle or on a rolling tripod or an ATV, and it can do mobile scanning. But the 400i, customers that had 400i can also make use of that new feature too as well. So we don't forget about the predecessor system, we just make it better. Of course, although the construction of the system may look less robust, but it still maintains a very high environmental protection of an IP64, which is dust-proof and splash-proof. So we did not downgrade at all because it's lighter and smaller and using different material in the construction. We still maintain a really high IP for demanding environments. Also very new to the 600i, and historically, if you know Riegl system, integrated cameras. So we've always had external Nikon or Canon cameras on top, but for the first time in the Riegl TLS lineup, we have 3 internal 12 megapixel camera, right? But nevertheless, we also offer an external Sony Alpha 7R4 camera, which is a proven camera in the photogrammetry world to be superior, crisp images. So option for our customers. And it just mounts right on top. All right. Also something new, we recently introduced something called a deep learning suite. I don't want to scare everybody with the word AI, but it's the first attempt of including and offering tools for a customer. Our workflow is acquire data, process the data, and geo-reference the data, tie it down to control, and spit it out. But for the first time, we are now offering additional tools, such as classification, automatic target detection, and so on. It's a new development for Riegl, and more to come. It is not part of the software, so if you're a user of RiseScan Pro, you can certainly download it on our members' website and install it, but it is a license-based, and more information, please contact or speak to some of our experts that we have available here today. But we have 2 software suite, 2 companion software for our kinematic, which is all of our mobile system, whether it's in the air, the ground, or midway between, which is your UAV, right? So that's RiProcess. But the other suite is RiseScan Pro. Both completely different. But in RiseScan Pro now, what is offered is a tool to automatically detect targets. Again, we still make use of cylindrical targets to reference our control. But these new targets, there are black and white targets, and they're flat. And you can print them out. You can use different material. I've done some testing, which I'll show you here shortly, just printing them out on a sheet of normal paper. I think it's 16 centimeter targets that I've used in my real-world testing. But if you are already a Riegl customer, you can actually find these targets, JPEG files, inside your computer. So if you're already a Riegl customer, if you want to download it and test them out, you can certainly come. Again, it is a license-based, so please contact one of our experts here for more information on that. But these targets can be used in many different, in 2 different ways, right? So we call a black or a white wedge. And you really just have to label it, and it's really user-defined, right? So you don't have to you're not dedicated to a specific size. You can print them out to a 4x4 sheet if you want to, or even just a 6" by 6" sheet if you want to. So all user defined. Now, real-world testing, and this is the first, right? So there's going to be more to come. You can see here where the scanner is located. I simply just put the target right over a nail with a dimple on it, and I just positioned it right over the middle. Now, there was no expectation on my end what I was going to get, but the results is absolutely incredible. So you just put the scanner near it, right? Preferably on a vertical wall, but if you don't, for this testing, I just put it right on the ground, right over a known control that we have at our Riegl office here in beautiful Winter Garden. So as long as the target is within line of sight of the scanner, the software can automatically detect it. Now, it does not have to be near the scanner. It could be 100 feet away from the scanner. As long as there are a number of required line scan on the target, the software can detect it, right? So we'll need 3 lines passing through the target. The scanner can detect it automatically, right in the center. So the targets I use for this test is just a regular 16 centimeter, and I just pulled up that PDF, printed it out, brought it outside, put some tape on it, and go from there. But of course, we don't recommend this. This is just for testing. You can make use of it however you want. And we define the targets because we use not just the dimensions of the targets, we also use the reflectivity of the targets too as well. And the reflectivity of the Riegl is not range dependent, right? So if you're looking at an object at 1 meter, the reflectivity is consistent also at 10 meters. So we use reflectivity and we use the target attribute size in combination to automatically detect the target. So different materials can be used, and when I say earlier, when I say you can use different material, you just have to define it, and it's very easy to define the target. You just, after you scan it, of course this is in the office post-processing, right? You then just have to select the black and look at the reflectance value, and then look at the white and look at the reflectance value on that, and subtract the black from the white. If it's greater than 3 dB, 3 decibel, the target could be used, and then you just take those values and put it right into the software, and it automatically detects it, which I'll show you the workflow here shortly. So as you're scanning, to make sure that the target is within range, you can operate it directly from an app, right? So on the left-hand side, you'll see the app, and you can clearly see the target is right in the scanner field of view. Yep. And then on the right-hand side, that's actually viewed in the software. So verification as you're scanning in the field that the target is captured, and then another one afterwards, you can see the vector pointing directly right in the center of the target. Okay, so this is how you define the target, right? We also have different type of targets too as well, so it's not just flat, it's not just cylindrical. But this is how you define the target. So it's all very flexible for the user to define. Now, to extract it automatically, you just pull up our registration workflow. And this is streamlined, right? So we don't deviate from this at all. Step 1, step 2, step 3. I always skip step 4 and go to step 5. That's because I just trust the process, I believe, I guess. Yeah, so once you define the target, create a target, the one you're using, you just pull up our tool called multi-station adjustment tool, and you just run through the process. And select the scan position, and then automatically defines the targets, okay? And then you just follow the workflow to absolute. Just simple as that, right? So that's the technology side. And now Jason's going to talk about how did he apply it. Right.
Okay, so how did I get up here? 1 year ago, I was at TUC, and I seen Tan demoing this VZ600i, and I went back and told my director, Derek, we got to get this thing. It is solid, and there's not going to be anything coming out like this for the next for the next 5 to 6 years. So he said, if we can make money with it, we'll get it. So I got in touch with Tan, and I said, can you give me a demo? His demo was 9,800 feet long. And he completed it in about 5 hours, and that sold the scanner. So I just wanted to throw that in. Okay, so I got a couple of DOT projects I want to share with you to kind of show you how versatile the VZ600I is. This first project is a North Carolina Department of Transportation project. This one's hot. Actually, we just turned it in like 2 weeks ago. So these are real-world projects here. We scanned 4,700 linear feet of road and 150 foot out from the center line. Our workflow was we put down survey control. There was 10 survey control targets on this project and 20 validation points. The validation points are just PK nails that we put in the side of the road to check our point cloud later on in the process. All our control, we shoot in with a total station and run digital levels through all of it. The field work for the control was 8 hours. Okay, so on this job was like 2.5 hours from our office. So we left the office knowing that we're going to have a long day. We're not coming back till we finish. We got the conventional guys going on the scan control, and then me and Nathan's here with me, we started scanning. Okay, we scanned approximately every 60 foot. Okay, we hit start on the scanner, pick it up. 25 seconds later, we pick it up and we move 60 foot. And the topo planner, suggests that distance from the height of your tripod. It doesn't matter how good a scanner you got, because your return, you can only move about 60 foot to get good coverage. We completed this scan in 5 hours. The complete project, and that's going cross country through people's yards, around the driveways. They wanted us to pick up the structures and the houses. As we scan down the road, every 60 foot, we would hit our control, and when we scan our control, we scan it from 2 sides, and we would get about 30 foot from each control point. We scan it from one side, then scan it from the other. And what that does, when you go to processing, if your rod gets kicked off or 18-wheeler comes by and blows it, you got something that you said, hey, wait a minute, there's something wrong here. We're going to exclude that control point. Okay, so we went from the scan to now the extraction part. We are 100% loyal to TopoDOT. We do everything in TopoDOT. So the client wanted the road profile, the power poles, the trees, bushes, driveways, curves, sidewalk, all extracted from this project. And actually, they only wanted 2,500 linear feet of this job. Now, you remember I said we did 4,700 feet. The reason is because there's a good chance on this job they're going to come back and want more data. Since we're up there, we had time that day, we went ahead and knocked out, extended out the job. Why not? We got time, we got an awesome scanner, we can do it. The total CAD time for this job, so 2,500 linear feet, is 40 hours. It was just real time consuming to go around the curbs and gutters and driveways and extract the trees and the poles and all that stuff. So you just got to keep that in mind whenever you price a job. If they want complete topo, it does get time consuming. Okay, and I also have data. This is real world stuff. So from the control point analysis tool, control point to data, our validation points I was telling you about. So we ran them in with the digital level. okay? We're picking up and we're not tying into another control point for 500 feet, okay? So these points are every 250 feet down the road, and look at the results. A lot of them are under 100th. That's compared to a digital level, y'all. That is absolutely amazing. And the TopoDOT gives a cool little deviation from the Z graph. All right, the next project is also from the North Carolina Department of Transportation. We utilize the grass median on this project. And the reason we did that is because the original control was ran down the grass median. Okay, so if you have original control, we always tie into the original control with the scanner. But if the points are, let's say, 800 feet apart, then we need to drop one of our controls, you know, at 400 feet. So we had 15 control points on this project. Linear length was 7,300 feet, okay? But our total scan distance was 14,600 because we went down one side of the median, turned, and went back up the other side of the median. And how we handled the scan control was when we went down one side, we scanned our control points, and when we went back the other side, coming back up the road, we scanned this exact same control points. So if we had any bus in our data or control, it would show. All right, so the total field work for our control was 6 hours. So, and then our scan, we had approximately 255 scan positions on this project. We did 255 scan positions in 7.5 hours. So it was a solid day. We finished 2.77 miles with the terrestrial scanner in 7.5 hours. To me, that's amazing. In TopoDOT, we're able to extract 2.77 miles in 14 hours. Do you see the difference there of almost 3 miles of a straight road, no curb and gutter, no topo, 14 hours. 2,500 feet with topo, 40 hours. It is a big difference there. Okay, so in RiScan Pro, we also check our control. And we check the control through the MSA report, and it kicks out a deviation that tells us how tight our control is to the scan. As you can see here, all the results, this is in hundredths of a feet, hundredths of a feet, and the data is really tight. And then we also, after it clears RiScan Pro, then we bring it into TopoDOT. And this is that almost 3 mile job, and everything, you know, we got some that are 200ths or whatever, but everything's around 100th or less, which is, I mean, this is real data here. All right, and also in RiScan Pro, sometimes the client, you know, may want a point cloud. So you want to give them as clean point cloud as possible. So in RiScan Pro, the one-touch processing wizard, there are a lot of tools that you can utilize, but I'm just going to kind of show one. It's mark moving objects. So you just click on mark moving objects, put in your parameters, and it will mark all your moving objects. You can classify those, or you can get rid of them, but you can classify them and hide them from your scan and send them, all of it, to your client. And boom, they're gone. And all this is done in RiScan Pro.
All right. So there you go, everyone. Jason has graciously shared his information with us. He's proven that the system is productive. He's proven that the system is reliable, and he's proven that the system can be used in project beyond the mile marker. And thank you, Jason, for that.
Thank you,
Before I let you go, I've been working on this magic trick for a little bit, okay? The scanner, I think it has voice command. I'm not sure, but let me see. Start scan. It worked. Will it work? It does. Thank you, everyone. Any questions?
Yeah, I have a quick one. Tan, yeah, just a real quick one. So the productivity, that's pretty amazing, to be honest. I mean, you can get a couple miles with a scanner. So from a business perspective, like, is that fill a gap? That fills a gap for you guys in your productivity line, where you're actually like having this middle step between maybe mobile, or there's a lot of projects. I mean, most projects are below 4 or 5 miles, really, or a lot of them. So, what do you think? So you went in pretty light traffic areas though, right? I mean, you kind of like, where you can get off the road, or not light traffic. I mean, you can get off the road and go to the side. You're not kind of in danger.
We are extremely safe. Yep, safety is our #1 priority. But sometimes it's quicker to deploy. I mean, about the same amount of control has got to be put down for this as the mobile. So that's the dangerous part, is having your field guys out, putting the control down.
Yeah. And it certainly is. And it's proven with the scanner, remote sensing, right? And when we do jobs for the DOT, or in any transportation, safety is first, where we would scan. So we want to scan as far away from the traffic. And of course, I don't think Jason waited until traffic died or scanned at 3 o'clock in the morning. I believe all these projects is done throughout the hours of the day, and heavy traffic on the highway. So no, it's flexible, and it's a very dynamic system where you can use it in very much any environment of the project. Yeah. Oh, and as far as filling the gap, yeah, this system does fill in the gap for a lot of applications, I think. Now with the lightweight and the flexibility and the user-friendly, I think it does fill in the gap, and it does open up doors for Riegl and our customers for many applications. Sure.
Thank you guys for that. All right, up next we have Paolo, all the way from